Okay, let's talk about the bones of the large animal, the horse and the cow, and kind of compare those to what the dog had or didn't have. Looking at the scapula, if we look at the cow right here, coming down this scapula, when you get down to the acromion on the end right here, here's our glenoid cavity down there, supraglenoid tubercles there. They've got an acromion right there, just like the dog had. Doesn't flatten out like the dog did, but they have an acromion. If you look at the scapula of a horse, they do not have an acromion. This spine will come down and just blend on in to that neck of the scapula right there. So you can tell the difference between a horse scapula and a bovine scapula by the presence or absence of that acromion. Looking at the humerus, neither horse nor cow has a supratrochlear foramen. This bone is solid down here. There is not a gap over that condyle. If you look at the proximal end of this bone, you can see the deltoid tuberosity here. They've got that. It's going to let you know they got a deltoideus muscle coming. But if you look at the proximal end of this thing, they each have something different than the dog had and different from one another. The horse, this is our deltoid tuberosity, greater tubercle here, lesser tubercle here. There's an intermediate tubercle in between the greater and lesser tubercles of the horse. So they have an intermediate tubercle right there. The bovine does not have an intermediate tubercle. Deltoid tuberosity is on this side here. So here's our greater tubercle here. Here's our lesser tubercle over here. They have a hook that comes off this greater tubercle and passes over that gap, intertubercular groove that will house that tendon of origin of the biceps brachii muscle. So they have a hook coming off the greater tubercle, projecting in a medial direction over the tendon of the biceps brachii. So horse, intermediate tubercle, cow, a hook off the greater tubercle. If you look at the radius and ulna on a horse and a cow, the two bones are fused. Radius and ulna are fused along the length. So they're not going to be doing any supination or pronation. They don't have enough digits to hold a spoon or a fork, so they don't need to be doing that. These are, I hit the glass. These are going to be fused together and built for stability. So here is our olecranon here, coming on down, ulna through here. Here's the radius over here, and they come down towards the distal end of that bone. And what you'll notice on the horse, this one's equine, you can clearly see the ulna up here, and it comes down here, and I can see a line right there. They're stuck together, but I can still see a line between the radius and ulna. It comes down, comes down, comes down, and about right here, that line will disappear, and we just see one bone down here, and you can't tell the difference between the radius and ulna. The ulna is still over here, and it comes down over here. Your lateral styloid process is still off the ulna. Medial styloid process over here is off the radius, but you cannot tell the two bones apart down here. That stops way up here. If you take a look at the bovine, here's our olecranon here, radius over here. So ulna's coming down, it's coming down. You can see a division right through here. You can see a division right through there, all the way down through here, and all the way down to the lateral styloid process. So you can visualize this ulna along its entire length in the bovine. Still fused together, but you can see it all the way down. If you roll it over here, it's even more remarkable on that lateral side. You can see the division all the way down. So in the equine, here's that lateral side here. You can see it, and it just disappears and fuses in, and there's no discernible ulna down there. So equine, I gotta watch that glass. Equine, bovine. Femur of these large animals. On the equine, at the proximal end of this, greater trochanter's there, lesser trochanter's here. There's the head of your femur there. Here's the third trochanter. The dog had it. It was just mentioned. There's just a slight roughening on the lateral side of that proximal femur, but there was no projection like this right here. Here is a third trochanter on the horse. So horse has a very prominent third trochanter. The other thing you'll notice is the greater trochanter has a cranial and caudal part. The caudal part is caudal and proximal to that cranial part there. So two parts to the greater trochanter in the horse. When you take a look at the bovine, greater trochanter right up in here, lesser trochanter over here, and no visible third trochanter down there. So one big greater trochanter. They have a funny knob down in here. Still, it's all greater trochanter, but there's no cranial caudal part to this thing up here. So there's our bovine proximal femur. And when you look at that little fovea capitis where the ligament femoral heads attach in, there's that hole right there is a drilled out hole to degrease the bone, but there's just a slight roughening there like the dog had. The other thing you'll see is the horse has this big gigantic notch out of this femoral head there. Again, there's a drill hole that we put in to degrease it. Big funny notch right there because they will have two ligaments attaching to that femoral head, whereas the dog just had one and the bovine has one. The horse will have two, and I've got those pre-dissected out in the lab to show you when we reach that point. So horse, bovine. The tibia looks like a typical tibia. The fibula would sit off to the lateral side over here, and what we see in this one's bovine, this one's equine. In the equine, there would be a little small piece of fibula up here. Now this has been boiled away and lost. It would come down and stop right down in here, and you'll be able to see that little piece on the full leg specimens in the lab, the articulated osteological specimens, and it stops there. The rest of the fibula is sitting down here, fused into this bone, and when you get to the distal end down here, the little lateral malleolus is this piece here. This isn't going to focus, and it's not set up to where I can get in there, but you're going to see a little division right down in here to where you can tell this is a piece of bone separate from this over here. So your lateral malleolus is fused to the distal end of that tibia in the horse, and you'll see a little line right there. In the proximal end, there'll be a little spike of bone up here. In the bovine, the proximal end, that little head of the fibula, is fused into the tibia, so it's not separate, and you can't really identify it other than saying it's this knob right here. The rest of it has been absorbed into the bone down here and fused into it, but the distal end will stay separate. So the talus, the trochlear of the talus, will sit in these two gaps here, but there's another articulation on the side over here, and that little piece of bone is missing. The lateral malleolus of the fibula is here, but it is not fused in the bovine. There's an extra little articulation here. So lateral malleolus is fused onto the equine tibia. Lateral malleolus is a separate piece of bone on the bovine tibia. And what you don't want to get confused with is if you start taking radiographs of the hock of a cow, and you come in and you're looking at, you're counting all the tarsal bones, and you think there's an extra tarsal bone up here. That's not an actual tarsal bone. That is part of the fibula. With the os coxae of the horse and the cow, I just have a piece of the cow here showing the important parts. This is the horse over here. Two things that will be different. When you look at the acetabulum of a horse, you have the big C-shaped articular surface right there, and there's the gap right there that the transverse acetabular ligament would span. So in this articular surface, there is one break in it right here. There's one break. If you take a look at the acetabulum of the cow, there are two breaks in it. Comes around here, there's a break right there. Comes around here, and there's a break right here. So there are two breaks right there in the articular surface of the acetabulum of a cow, only one in a horse. The other thing that you will see is when you look at the ischiatic tuberosity in a horse, it is a flat line right there. If you take a look at it in a cow, it is triangular. Triangular in the bovine. So they've got that difference as well. On the front limb, the dog, when we get to the carpal bones, you remember in the proximal row, we had an intermedial radial carpal bone, we had an ulnar carpal bone, and an accessory carpal bone, and those, call it intermedial radial in the dog because these two bones were fused in the dog. So that's why the little slash there is representing a fusion. And in that distal row, there was carpal bones 1, 2, 3, and 4. Okay, in the equine, and you'll recognize this now by this point in time. This is medial and this is lateral, left to right there, the way we're doing this. So in the equine, on that proximal row, there's a radial carpal bone. There is a separate intermediate carpal bone, then ulnar and accessory. And on this distal row, you may or may not have carpal bone number 1, so I'll put it in parentheses, but you'll always have carpal bones 2, 3, and 4. So in the corpus of the horse, they can either have 7 bones or 8 bones. It depends whether this one is there or not, but these two will be separate. In the cow, radial and intermediate carpal bones are separate as they were in the horse. And on that distal row, 2 and 3 are fused. We'll use that slash for a fuse, like I did up there for fusion. So 2 and 3 are fused together into one structure, and 4 sits here. So when you look at the number of bones in the corpus of a cow, you've got 6. This one is composed of 2 different embryological pieces, but there are 6 separate bones in the corpus of a cow. In the back foot, let's jump over here to the pes, and we're just in the short bones of these areas here. So dog, horse, cow once again. The dog had a talus, a calcaneus, and a central tarsal bone. Remember, there's really not a proximal and distal row in the back limb like we had in the forelimb. So we'll put these 3 up here with names, and we'll put the ones with the numbers in this distal part down here. 1, 2, 3, and 4. But you recall 4 kind of extends up here, and the central is kind of tucked down over here. But there were our 7 bones in the dog. So in the horse, once again, we have a talus, calcaneus, and central carpal bone. And down here, central tarsal. I think I may have said central carpal. Central tarsal bone. We have 1 and 2 tarsal bones fused together into one structure, and 3 and 4 will sit as separate entities. So 1, 2, 3, 4, 5, 6 separate bones in the horse. And in the cow, it gets real dodgy here. Talus, calcaneus, central. They have tarsal bone 1. Tarsal bones 2 and 3 are fused. And tarsal bone 4 is fused to the central tarsal bone. So they have 5 separate bones that you will see on a radiograph. So those are the short bones in the corpus and tarsus of our large animal when compared to the dog. Okay, now this diagram, we are looking at the carpal bones, cow on the left, horses on the right. And if you look here in the proximal row in the cow, in the corpus, radial, intermediate, ulnar, and accessory. And down here is carpal bone 2 and 3 fused. You can see the 2 different colors. There's carpal bone 4 over there by itself. And in the horse, we see our 4 in the proximal row again. Radial, intermediate, ulnar, and accessory. And then here is carpal bone 2, 3, and 4 showing right here. If they have one, it's not showing this picture, but it would be kind of around the back side of this over here and out of the picture. But we're seeing 2, 3, and 4. So these are the ones that all horses will have. And right here you can see this little orange coloration up here. I mentioned earlier that you could see the radius all the way down on a cow. And on the horse, just that little piece, you can see a fusion bone at the articulation. And they're designating that little piece of the ulna right there. So that shows up in that picture as well. So there are the carpal bones. And in the tarsal bones, once again, we've got the cow on the left and the horse on the right. So on the cow, we have our talus and calcaneus. And here is that fused central and fourth tarsal bones right there. Here is the fused second and third tarsal bones. And here is tarsal bone number 1 right there. This is something else we'll talk about in a moment. In the horse, here's our talus calcaneus, central right there. Fused, 2 different colors, tarsal bones 1 and 2. Here's tarsal bone 3 and tarsal bone 4 right there. I went ahead and printed out this page here, so y'all can screenshot this if you'd like. The metacarpus and digits of the large animals. The horse. The third metacarpal bone is functional, meaning it's weight bearing. The second and fourth metacarpal bones are vestigial, and they're called splint bones. And the horse only has the third digit, and there will be 3 phalanges of proximal, middle, and distal phalanx in that one weight-bearing digit. No phalanges associated with those 2 splint bones. In the cow, metacarpals 3 and 4 are weight-bearing, and these 2 bones are fused. These will be fused together. You can still see the groove between them clearly. They'll be a little bit separated down at the distal end. And the 5th metacarpal bone will be vestigial. Not as much there as you see in these splint bones up in the horse. And there are 4 digits in the cow. 3 and 4 weight bearing. These will each have 3 phalanges in them. These other 2 digits will be 2 and 5. And those are the dew claws. The little pieces of bone in there, we will not worry about those. They don't articulate with anything, but you'll have a couple little vestigial pieces of bone down in there representing phalanges, but they don't articulate up with any type of 5th metacarpal, and of course there's not even a 2nd metacarpal vestige to articulate with. So when we come back here and take a look at this picture, here's the horse, here's metacarpal number 3. Here are our vestigial metacarpals 2 and 4, called splint bones. And so sometimes they will call these the medial splint and the lateral splint, and that's fine. And here is our digit here with proximal, middle, and distal phalanges. And in large animals, especially with a horse, they will call these P1, P2, and P3 just to get through them quicker. The other thing you will hear these referred to as the long pastern bone, P-A-S-T-E-R-N, the short pastern bone, and P3 is the coffin bone. The hoof will sit here like so. P2, the proximal end of it will be outside the hoof. P3's entirely down within that keratin structure as it's in a coffin, so that's where it gets that name, coffin bone. Over here on the cow, here's our fused metacarpals 3 and 4. There's a little vestigial fifth metacarpal. And here are the two weight-bearing digits. Here where I said the ends of those metacarpals would be separated at the end right there by a little gap. Here's our P1, 2, and 3 of the two weight-bearing digits 3 and 4. And the dew claws will be little things that kind of sit back over here like so, around the back of the limb. And I've got some plastinated bovine feet with all the skin on, showing you those dew claws back there, so you'll be able to take a look at those. But they do not touch the ground unless the animal is sinking down in mud, and you'll see those tracks. If you think of deer tracks in the mud, or you've seen pictures of them, you'll see those two tracks like this, and you'll see those two little dots back here behind them right there. That's the dew claws hitting down in the mud at that point. Metatarsus and digits, it's the same as a forelimb. You're just changing palmar to plantar and carpal to tarsal. So the horse, there's no difference. The cow is the same, except the second metatarsal bone is vestigial and not that fifth one. So we had a vestigial metacarpal on the lateral side of that limb up here. And the hind limb, it's medial, and there's that little piece I said we'd come back to. There's a little piece on the medial side that will be vestigial. Everything from here down will be the same. Now the joints of all these bones, starting up there, the humeral joint in the forelimb, and the sacroiliac joint in the hind limb, these will all be named accordingly. Front limb here, when we get down here, we got antebrachiocarpal joint, middle carpal joint, carpal metacarpal joints. They're all named the same. When you get down here, metacarpal phalangeal joint, proximal interphalangeal joint, distal interphalangeal joint, that's all the same. One of the new things you may hear, or you will hear, this will be called the fetlock joint in the horse. They'll call that in the cow, but I don't know. I guess you just see horses a lot more and you deal with horses more. I guess we tend to eat the cows. But fetlock joint right there. This one right here they will call the pastern joint. Pastern joint. And this one down here in the hoof will be called the coffin joint. So you will hear those different names. Collectively, the carpus, people will call this the knee joint, but that is not the knee of the animal. The animal's knee joint is a stifle joint, so I would not call this the knee joint. You're just asking for problems. It's not the knee. We've got another knee in the animal, so please don't use that. In the hind limb, the tarsus, they will call this the hock joint. They'll do it in dogs sometimes, so it's not uncommon to hear it there, but they will call it hock when you get to large animals. So the tarsal joint will be the hock joint right in here. Tarsal curl and everything in this region. And that leads us to the last point on sesamoid bones. Proximal sesamoid bones on the palmar or plantar side of the metacarpal or metatarsal phalangeal joints. So those are in the same place as the dog. Familiar with those? There'll be a pair right there. Distal sesamoid bones, this is a new one. This one's also called the navicular bone. This one is at the coffin joint, or that distal interphalangeal joint. See, I didn't want to write distal interphalangeal joint, so I wrote coffin joint. See how that works? And this is just an expanded diagram. Here's P1, P2, and P3. So right here, your metacarpal bone would have been coming down in here, so your proximal sesamoids are sitting right here at your metacarpal phalangeal joint, And here's that navicular bone sitting right here. It'll be on the palmar or plantar side of that distal interphalangeal joint between P2 and P3. So those sesamoid bones all on the back side of those limbs.